Okay, so here we come to the last equation, which is if we have uh, absolute value included in the function type. Okay, so in here, all the time, the domain for the absolute value function, it will be from minus infinity to infinity, which means it's R. Okay, now if we have learned from the previous term that if we have f which is equal to absolute value of x, okay, we can redefine this as piecewise function. X, it will be in here x square, or x when x is greater than or equal 0, the 0 of the function or the expression inside, and minus x when x less than 0. Now, this is different because this is a quadratic function. So this is not like this, but we can convert it to a piecewise function. Let's see how we can do this. So f is equal to absolute value of x squared minus 1. So in here, we can take the same function x squared minus 1 and minus the function which is minus x squared plus 1. Okay, this is when x is greater than, for now we have to find the zeros for this function actually, or the expression inside. X squared minus 1 equal to 0. That will give me x squared equal to 1, then square root, so I will have positive negative 1. So this is when x is greater than the highest value, which is in here 1. Okay, let's put equal sign over here. Or when x is less than minus 1. Okay, and over here we can say minus x squared plus 1 when x is between minus 1 equal, because we haven't put equal sign for the minus 1, less than 1. Okay, now sometimes you can find this expression twice, once when x is greater than or equal 1, and they can write it again over here when x less than minus 1. I prefer to write it once, so as you like. So x squared minus 1 when x is greater than or equal 1, or when x less than minus 1, and in here in between I have to give them to give the function the opposite sign. Okay, now we can find the derivative. So f prime is equal to the derivative of the first one. This is 2x. Okay, this is 0. This is when x is greater than 1, and or sorry, when x is less than minus 1. Okay, the second one is the derivative of this is minus 2x. Okay, be careful, I removed the equal signs once I found the derivative. Now this is when minus 1 less than x less than 1. Okay, now I will tell you why I removed the equal sign. So in here, let's find, after finding the derivative, we have to make the derivative equal to 0. So zeros, this is by making this equal to 0, 2x equal to 0, and making the second one minus 2x equal to 0, and both of them, they will give me x equal to 0 at the end. So this is the 0 in this derivative. So in here, the undefined values, I can say that f prime is undefined at x equal to positive and negative 1. Now, how come? How I know that? So now, f prime, okay, to see if f prime or this is a defined value, or can I put the equal sign or not at 1 and at minus 1. Let's find f prime at 1, okay, from the right. Okay, so this is from the right. F prime of 1 from the right is equal to 2 times 1, which is equal to 2, and f prime of 1. From the left side, that's it. I have to substitute over here. So minus 2 multiplied by 1, this is equal to minus 2. Since 2 and minus 2, they are different. They are not the same. That means f prime is, or the 1 is in here, undefined value for f prime. Okay. The same thing will happen once you find f prime of minus 1 from the right and from the left. They will be different. So that means x equal to positive minus 1 is in here are undefined values for f prime. Okay, so the zeros in here we found the 0 only, and undefined values we have positive, negative 1. And what about if they are included in our domain? Yes, all of them included in our domain since our domains are. Now let's find out the local points. So in here we have three values. We have minus 1, we have 0, and we have 1. Let's substitute any value less than minus 1. Let's say minus 2. Be careful, I'm substituting in the derivative. Look, how can I substitute this? This is a piecewise function. So let's say minus 2. Minus 2, I have to substitute it in x less than minus 1. So minus 2 multiplied by 2, which is equal to minus 4. So this is negative. Let's see a value between minus 1 and 0. Let's say minus 0.5. Now for minus 0.5, it's not less than minus 1. It's not greater than 1. It's between minus 1 and 1. Yes. So in here, minus 0.5, I'll substitute it over here. Minus 0.5 multiplied by minus 2, this is equal to 1. So this is positive. Okay. Now after the 0, let's take 0.5. Again, it's between minus 1 and 1. Okay, so 0.5 multiplied by minus 2, this is equal to minus 1. So this is negative. And 2, for the value 2, it will be positive, because I'll substitute it over here because it's greater than 1. So in here I have down, up, down, up. So that means I have local minimum at x equal to minus 1 and positive 1, so positive, negative 1. Okay, and I have local max at x equal 0. That's it. That's it. This is the end of question, or the part 2 and the 3 in here. So in here, let's check this. So we have solved in here how to find the critical points, okay, of a given function. The questions from 7 to 22. Okay, let me just give you the answers for all the questions, just in case if you would like to take a screenshot or something. So in here, this is, you can find in here. Okay, so you can find the answers for question 7 and question 8. The one I left the part which is finding the local points for you. I already found in here. In each question you can find me, or you can just find the critical numbers. Okay, now if you would like to find the local points, you can directly substitute in the derivative and find if you have local maximum, local minimum, or neither. In here, this is for question 9. Some of these questions already solved them in the videos. This is a question 10. Okay, and this is question 11. And in here, question 12. And over here, we have question 13, question 14, 15 and 16. And over here we have 17 and 18. And over here we have 19, 20. Then we have 21, 22. Any question, if you would like to ask me about any question that we haven't solved in the videos, you can just write a comment and give me the number of the question, and for sure I will help you, or I will record another video that's included by that question. So next video inshallah we'll start with the next part.